Hiya guys, Mr. Mackey here. Now yesterday I was showing you how to find the nth term of geometric sequences, like this one. And I set you the challenge to find not only the nth term of this sequence, but the 6th term of it as well. So let's find the nth term. Firstly, what is the first term of this sequence? So 5. So we write 5 here. Now, what's happening every time? What are we multiplying by every time? We're multiplying by 3 every time. So the rule is 5 times 3 to the power of n minus 1. So to find the 6th term, all you've got to do is you've got to do 5 multiplied by 3 to the power of 6 minus 1. 6 minus 1 is 5, so you do 3 to the power of 5, and then you just times that by 5. So 3 to the power of 5 is 243. Times that by 5, and you'll get the answer, which is 1,215. Now, today we're going to move away from geometric sequences, and we're going to be focusing on the last of the sequences this week, which are called quadratic sequences. Now these are probably the most difficult sequences to follow because they're very different in terms of linear and geometric. The nth term is a bit more harder to find as well, but we're going to focus on finding the nth term tomorrow. Today we're going to focus on generating sequences with them. So firstly, how can we tell that a sequence is quadratic? Now this is an example of a quadratic sequence. We can already tell that because it's not being added or subtracted by the same number, it cannot be linear. And also it's not being multiplied or divided by the same number either, so it cannot be geometric. So how can we tell that this is a quadratic sequence? The first thing you have to do is you have to find the difference between those numbers. So this one, the difference between them is 2. The difference between this one is 4. The difference between this one, 6. The difference between this one, 8. Secondly, we find the difference between the differences. That sounds a bit strange, but I'll show you. So the difference between the 2 and the 4 is 2. The 4 and the 6, 2. The 6 and the 8, also 2. And that is how we know if the difference of the differences is the same, then the sequence is quadratic. So this one is a quadratic sequence. Now, how can we create more? Well, if we know that the difference between the differences is the same, the next difference will also have a difference of 2. So the next term will be increasing by 10. So the next term of this sequence would be 31. Because it's increasing by 10 because the difference is 2. To find the next term of this sequence, there's going to be a difference of 2 again. And that means that we're going to be adding 12 on each time. So the next term will be 43. And we can carry on with this. It's quite a difficult thing to remember because you need to remember that the differences will increase by 2 each time. But once you've got the hang of that, generating quadratic sequences are quite simple. Now let me show you an example of an nth term and how we can create a sequence from that. So, this is what a quadratic sequence's nth term looks like. What if we don't have the sequence? How can we tell that this is the nth term of a quadratic sequence? So remember when I showed you those quadratic expressions in Algebra Week and I told you how they show they're quadratic? Well, it's the same for this. This is what tells us. If the highest indice in this expression is to the power of 2, this is a quadratic sequence. But I can show you another way. Let's generate the first 5 terms of this sequence. So for term 1, you do 1 squared minus 3. Okay, so 1 squared minus 3, so 1 times 1 squared is 1, minus 3 will get us negative 2. Let's now go to the second term. 2 squared minus 3. Well, 2 times 2, 2 squared is 4, minus 3 gets us 1. Let's do the next one. 3 squared minus 3. Well, 3 times 3 is 9, minus 3 gets us 6. Fourth term. 4 squared minus 3, well 4 times 4 is 16, minus 3 gets us 13. And the fifth term, 5 squared minus 3, well 5 times 5 is 25, minus 3 gets you 20, whoops, wrong pen colour, gets you 22. We could also do this for finding big terms. What about the 10th term? Where you do 10 squared minus 3. 10 squared is 100, minus 3 gets you 97. So this is another way to show you that the sequence is quadratic. Yes, we got the nth term with the highest indice being to the power of 2, but another way to prove it is exactly what I just showed you. The difference between negative 2 and 1 is 3. Between 1 and 6, 5. 6 and 13, 7. 13 and 22, 9. And 22 and 97, they're different terms, so we don't go any further. But the difference between those differences are all 2. And because those differences between those differences are the same, this is a quadratic sequence. So it's still the same to generate sequences. You just substitute the nth term with the term we're using, and you can create a sequence from that. But now we know how we can prove that this sequence is quadratic. It's awesome, isn't it? Quadratic sequences could also look like this. Do we have to do anything different in terms of substituting in? No. So for the first term, we do 2 times 1 squared plus 1 plus 3. So 1 squared is 1, 2 times 1 is 2, plus 1 is 3, plus 3 again, it gets you, the first term is 6. So for term number 2, you do 2 times 2 squared plus 2 plus 3. 2 squared is 4, 2 times 4 is 8, plus 2 again is 10, plus 3 equals 13. Let's do the next one. So for the third term, it's 2 times 3 squared plus 3 plus 3 again. 3 squared is 9, 2 times 9 is 18, plus 3 is 21, plus 3 again equals 24. For term 4, you do 2 times 4 squared plus 4 plus 3. 4 squared is 16, 2 times 16 is 32, 32 plus 4 is 36, 36 plus 3 equals 39. Now let's prove that this is a quadratic sequence. I know we got the nth term as well, but let's just do it. So the difference between 6 and 13 is 7. 13 and 24, 11. 24 and 39, 15. What's the difference between those differences? 4. May not be 2, but they're still the same. So we've also now we've proven that this sequence is quadratic as well, because we found the difference between those differences. It's pretty straightforward when you figure it out. Now, let's move on to the challenge. So here is your challenge for today. I have 3 sequences. 2 sequences outlined here, and the nth term of one at the bottom. I want you to find which 2 of them are quadratic, and explain why the one that isn't quadratic isn't quadratic. I also want you to find the 6th term for the ones that are quadratic. So 2 things I want you to do: find the ones that are quadratic, and then find the 6th terms for those 2. Pretty straightforward. Tomorrow's going to be a complicated one, a great way to end sequences week. I'm looking forward to doing it. Let's see how confident you are in quadratic sequences. Good luck. See you tomorrow, guys.